Hello all, welcome back. This is continuation of the previous lecture, that is pMOS transistor as pull-up in complementary mode. In the previous example, what we have seen is the pMOS transistor when used as a pull-up device, then it is called as pseudo pMOS. In the pseudo pMOS, we have got good high, but not good low, which is not zero. That was the problem faced by the pseudo pMOS or pMOS transistor as a pull-up device. Now, using pMOS device in complementary mode solves that problem. And here you can see when the input is 0, output is VDD, which is good high. When the input is 1, output is at 0, which is good low. Good high and good low both are possible by using this by using this pMOS transistor in complementary mode. That means both the inputs are tied together and the input is commonly applied. When the input is low, when the input is low, this pMOS device will be on and the NMOS device will be off. As the pMOS device is on, the supply voltage which is existing here, VDD, comes as the output, which is almost equal to VDD. When the input is made high, as we have discussed, pMOS device will be turning off. When pMOS turns off and NMOS is turned on, there is a possibility of this output to discharge, which is out present at the capacitor, load capacitor, that will discharge to this pull down device to the ground, and output completely becomes to 0. So a good logic 0 is also possible. Now this transfer characteristic curve, the whole transfer characteristic curve is now divided into 5 groups, 5 regions, 1, 2, 3, 4, 5. During region 1, one device will be on, pull up device will be on and pull down device will be off. So in that condition, what happens? Let us see. Region 1, when the input is from 0 to less than VT, with threshold less than threshold voltage, then pull down device, pull down transistor will be off and pull up transistor will be on. On means in linear region. So no DC current or the static current flows in this region, and the output voltage is VDD. In region 2, what happens? Input voltage is slightly above the threshold voltage and less than the VINV, which is 50% of VDD. So it is less than 0.5 VDD and above VTN. Now both the devices are in active region. Now both the devices uh, are in on state, but the pull up transistor is in linear region. Current increases as Vin increases from VTN to VINV. Same current flows through both devices because both the devices are on during particular state. So both the devices current flows, but of reverse direction, because one is NMOS and another one is pMOS. In third region, when the input voltage is equal to VINV, which is 0.5 VDD, then both the devices enters into saturation. During this state, a peak current flows, which is represented like this. IDSN is equal to IDSNP with a reverse direction. During this region 3, a peak current flows, which is called dynamic power dissipation. Except that short time, current flow does not take place in the device. Rest of the two regions are similar to region 2 and region 1. So that is why much explanation is not required. What happened in this region, if you reverse this, that will give you explanation. I hope you understood. Thank you.